All right, and I said we'd have at least another type of property in this section, and we're actually going to go back to something we learned in the previous section. We had talked about symmetry there, but in the previous section we had talked about symmetry graphically speaking. Right now we are going to revisit symmetry, but look at it algebraically. So symmetry algebraically. And let's see here, so I'll put some definition type things up here. So even, or y-axis symmetry, we talked about in the last section. This means, algebraically speaking, what this means is f of x is even if f of negative x is equal to f of x. And odd, so that was origin symmetry there. F of x is odd if f of negative x is equal to negative f of x. So those are our two algebraic definitions of even and odd symmetry there. And I'll go ahead and do at least one example in this video to kind of get us started with this concept. And if it gets too long, I'll put some more in a separate video. And let's see here. So let's look at an example here. Let's say I want to know, is f even, odd, or neither? So is f even, odd, or neither? And let's say for this example, let's say f of x is equal to x to the third plus x. Now, the nice thing about these algebraic definitions is they both start the same way. They both start with f of negative x. So either way, when you're doing a problem like this, I would always start by having my first step be, well, let's go ahead and find f of negative x. So f of negative x, we're going to replace every x we see with a negative x. And then might as well simplify it. In this case, negative x to the third is negative x cubed, plus negative x is negative x. Now, right now, we can start checking. Okay, is it going to be even? I always check even first. I don't know why I check that one first, but just my own process. So for even symmetry, what we get here for f of negative x, it would have to be exactly the same as what we started with. And what we started with here, I'll underline it in yellow, is x to the third plus x. Now, what we have here for f of negative x, that is not exactly the same as what we started with. So this is going to be not even. And now I'm going to move on and say, okay, well, it's not even. Is it odd? And for it to be odd, this would have to be the exact opposite of what we started with, because for odd symmetry, f of negative x has to equal negative f of x. And now some people are really good at just looking at something like this and saying, oh yeah, that's the opposite. And I imagine what they're doing is saying, probably looking at each term and saying, okay, well, x to the third and negative x to the third, those are opposites. X and negative x, those are opposites as well. And that's fine. If you can handle that, that's okay. If you can't, if you think that's going to be confusing, what I would suggest is at this step, factor out a negative 1. And if you do that, it should make it a little bit easier to see, okay, is this the opposite of what I started with? Because if it is, you're going to have a negative out in front and then exactly what you started with. The negative is what makes it the opposite of what you started with. In this case, sure enough, we do have the opposite. We have a negative in front of our original function, which was x to the third plus x. And because we have that, we can say, okay, well, this is odd. And I'll go ahead and do 2 more examples like this. I'll put them in a separate video, though. I don't want this one to get too long.